Okay, welcome. By this point in time, you should have completed the videos that take us through some of the theory and some of the vocabulary that we will use as we start to conduct this analysis. You also should have completed the environment setup video and downloaded Rnr Studio and a sample data set that we're going to explore as we go through this practice analysis. Now, I want to also set up the business problem or the business question that we're going to try to answer through this analytical approach and give you a little bit of context around that. So for this particular scenario, let's pretend that you work for a company that manufactures surgical suture, both the filament or the suture and the needles themselves. Your company has seen an increase in scrapped or thrown away units due to a high number of defects, and your manufacturing director asks you to help her identify where she should direct the team's limited resources in order to have the largest impact during their quality investigation, and she wants that investigation to occur for each product. Now, if you're unfamiliar with sutures, there is a how it's made video that you can watch on YouTube that I've pulled a still from here in this slide. I'll also leave a link in the comments of this video or in the supporting materials so that you can go and watch that if you want to learn a little bit more about how that works. But I want to stress that anytime we are conducting an analysis, it's really, really important to start with a business problem or a business question, and to make sure that we really thoroughly understand that question or problem so that we can deliver something against it in a way that will drive value for our business. Lots of times I see analysts get pulled down this analytical rabbit hole and do lots of really interesting things with data, but sometimes perhaps lose sight of the question that is trying to be answered. And when we have that drift, we end up introducing a lot of waste into our analytical workflow. So as we're going through this analysis, continue to ask yourself, is this helping me answer the question, where should my managing director, or pardon me, my manufacturing director allocate her resources to have the largest impact possible? Now, giving some additional details here, we can confirm that, again, this analysis needs to be done for each product in our catalog, and our goal is to identify the most common underlying defects so that we can prioritize the way in which we deal with them. If we can approach just a couple of defects and drastically reduce our scrap rate, that's what we want to do. We don't necessarily want to be chasing what sometimes people would call like onesies or twosies, basically one-off mistakes. We want to try to find the area where there appears to be some sort of systemic flaw that needs our attention. Now, in this hypothetical situation, let's pretend that you've met with a colleague who recommends that you conduct a particular kind of analysis called a Pareto analysis for each major product in your catalog. And let's also have as an assumption that this analysis is going to become a standard report, one that's very likely to be conducted at the end of every single month for the foreseeable future, lending itself to the idea that we really want to make sure that we automate this process so that we're not having to crunch a bunch of numbers every single month. We'd rather write an automation script and let our computer do that for us. Now, once we get into the actual analysis, I'll take you through the steps of doing a Pareto style analysis or building what's called a Pareto chart, but it can be helpful to start with the end in mind. So just as a reminder, during this hands-on session, we're going to be using R to write code that will help us explore these defects, and we're going to create something like this graph below in order to help us analyze each product and its related defects. Now, the way that a Pareto analysis works, it's based off of what they call the 80-20 rule, and that is, it's not necessarily a perfect rule, but it is the idea that 80% of any problem or any gains or any increases in efficiency can be accomplished by tackling 20% of the opportunities available to us. Applied more directly to this context, it suggests that if we approach 20% of the different defect types and try to find solutions for them, that should address about 80% of the units that are being scrapped. And when we look at this particular chart that's drawn out here on the bottom of our screen, we can see that we have across the bottom different defect codes and the number of times that they are occurring stacked up in these bar graphs. And then we have a line graph that is tracing the cumulative proportion of all defects that are accounted for. So with our heat test failure, that has occurred 447 times. We've had to scrap 447 units as a result of this heat test failure. And we can see that that accounts for 40% of all of our defects. So if we were to address that, we would eliminate 40% of the waste that is coming off of this particular production line. If we were to address that and our delamination issues, we would actually be addressing a little bit over 60% of the defects that are occurring with this line. And if we were to address those two things and the structural integrity issues that are being observed, we'd get pretty close to an 80% reduction of the number of units that are being scrapped. So the idea here is that if I were to knock out these three problems, I would actually have an outsized impact. I would account for 80%, in this case it looks like it might actually be closer to 75% of the scrap that is coming off of this line. Now in the next sections we're actually going to start by giving you a soft introduction into Rnr Studio. I'll take you on a tour of the software and teach you some of the basic functions, and some of the, I'll introduce you to some of the ways that R evaluates code and conducts operations. And then in another hands-on video or two, we'll actually dive down and build this kind of analysis. I look forward to seeing the next one. Thank you.